Hi there. I'm going to be talking through this paper on the role of corpus ordering in language modeling out of Portland State University. So this paper really looks at the idea of curriculum learning in more detail and specifically wants to understand how ordering on the basis of difficulty as well as how one actually integrates an order into a particular curriculum impacts downstream performance on both perplexity and loss as well as on fine-tuning tasks. So we have a pretty comprehensive evaluation of these methods, which I think is good, but the paper is pretty straightforward. So more generally, curriculum learning, it's the idea that the way in which we structure our corpus that we train on actually has an impact on downstream performance. So you can imagine a lot of ways in which we can think about this. So more specifically, we can understand complexity. By complexity, you could do a very easy cursory way of handling this and looking at just like a sentence length, right? But instead in this paper, in addition to sentence length, the authors investigate text on the basis of its readability as well as lexical richness. And they also do this at two different levels, at the sentence level and the document level. They are then going to divide this into bins from which we generate training batches, and that is the basis upon which we construct our curriculum. So the sentence level complexity, like I said, very basic level. You can have it be the length of the sentence. That's pretty straightforward, and they do that. So 2 to 5 words, 6 to 10 words, and so on. They have more information on that later, but what I think is more unique here is looking at document level complexity. So you might remember from say middle school, there were these like lexical reading groups, like reading at a like 6th grade level, etc. So they specifically are using this FRE score. That FRE score stands for Flesh Reading Ease. Right there. And yeah, that is going to give us a sense of how complex a particular document is going to be. So we're looking at the number of words as well as the number of sentences and the number of syllables. So there's a nice calculation here that's not over parameterized. So they also look at type token ratio score of each document, a ratio of the number of unique words to the total number of words in a document. And then, yeah, having word types accounted for in some capacity has been shown to be helpful. So, like I said, that sort of gives us a sense of complexity. What we now care about is how we actually order the corpus. So they specifically mentioned 2 different methods in which they construct these bins. So I'll just use that like sentence length example. So we can either accumulate them in a way where they're like unique and distinct, or we can do this stepped version. So in the bin version, you can imagine we first train on the 2 to 5 word sentences, we then move to the 6 to 10, and then so on and so forth. In the stepped case, what we're going to do is we're going to start out with that 2 to 5 case, and then we're going to pile on top of that the 6 to 10 word cases and train on all of those sentences. So 2 to 5 words as well as the 6 to 10 word sentences. And what this is going to do is ideally give us some ability to not catastrophically forget our basic grammar and our 2 to 5 word sentences. That is the idea here. They want to look at both of these as they're maybe married to both of them. So they are specifically using BERT-base here, the uncased version, and then they mention a little bit on the specifics of how they're actually going to do the training as well. And yeah, I won't get too much into that. Like I said, the other good thing that they're doing here is they're not just saying what is the loss, what is the perplexity of the models, but how do they perform when you're fine-tuning on glue. So I'll mention some other cool things later, but I want to highlight some of the output here. So what they're showing in this table 3 here are the results of bins derived from sentence length increasing to decreasing. So when I say increasing to decreasing, that is a question of whether the sentences are getting longer as you progress through training or shorter as you progress through training. And what they show is that generally speaking, the cases that like first row for bin length are going to increase performance versus a vanilla model that one is training. You can see some cases in which the decreasing model also performs relatively well, but it's never too significant relative to that increasing case. In Table 4, we're looking over the training when we're deriving bins based on document level complexity. So that's like the like what grade level score it is, or that neat calculation I shared before. And the results here are a little more mixed in terms of what is the best approach. So in this case, the easy and hard here, that's going to refer to whether or not you go from easy to hard or hard to easy. And as you can see, there's like definitely some cases in which, especially for MNLI, the hard to easy works out far better. So I think that this is a somewhat interesting result. We just get to anything that they specifically note. So the bin TTR hard does well in terms of validation, loss, and perplexity. However, it is the poorest performing model when measuring in terms of average clue score after fine-tuning. Overall best performance is achieved by the bin FRE hard. So yeah, that is another thing that they also mention here that I think is relevant. So yeah, these loss and perplexity scores don't necessarily have correlation with what the fine-tuning performance is, and I like that makes sense, right? These tasks are different than what we're actually pre-training on. So, however, we would still hope to see some correlation there. One thing I can comment more in the reading group on some ideas for why that may be arising. So. Let me see if there's anything else I want to comment on. Yeah, so like I said, sharing from that last table, the anti-curriculum going from hard to easy evidently works better in some of these cases. I don't think you can say like it is by far like the best case. The other experiment that they're going to run is for stepped versus binned. So like I said, stepped is when we integrate more examples from more complex or perhaps less complex examples as we go through training while keeping our initial words as well. So in Table 5, what they show is that there's kind of a mixed bag of how well that actually impacts things. You can compare the scores sort of across here. The average case, the step doesn't actually help all that much. However, if we're looking at loss and perplexity, going from easy to hard with step data is going to give us the best perplexity as well as the best loss. There's some like notable difference here, especially in that perplexity number. So I don't think we can totally write that off as insignificant. They have some interesting hypotheses for why binning versus stepping might not totally be a valid way of looking at this issue. So looking at the ratio of common word types between any two consecutive bins, they found an overlap of up to 40%. And what that means is that there's more that can sort of carry over than we might think in a more straightforward binned setup. So I think what that implies is there's almost a degree of steppedness insofar as the vocabulary is concerned, not in terms of sentence complexity. So I think this is a pretty interesting finding. We can talk more about that. Otherwise, yeah, the last sort of thing that they're looking at is things oriented around compute resources as well. This paper came out as Sustain NLP, and they specifically talk about the value of having curriculum learning towards this end of having more green means of training language models, which is always a welcome thing. So yeah, they talk about some other related work here that I'm definitely very interested in, but that is it for this paper. General findings are that there may be benefits to doing curriculum learning in this way, and there are a lot of disconnects between perplexity and loss and fine-tuning accuracy downstream for these models. Thanks.